My name is Vanshika Hinduja and my topic is nuclear magnetic resonance spectroscopy. Spectrometry. Spectrometry is the measurement of the interactions between light and matter and the reactions and measurements of radiation intensity and wavelength. Or we can also say that spectrometry is a method of studying and measuring a specific spectrum, and it's widely used for the spectroscopic analysis of sample material. NMR spectroscopy. It is a spectroscopic technique to observe local magnetic fields around atomic nuclei. The sample is placed in a magnetic field and the NMR signal is produced by excitation of the nuclei sample with radio waves into nuclear magnetic resonance, which is detected with sensitive radio receivers. NMR instrument allows the molecular structure of a material to be analyzed by observing and measuring the interaction of nuclear spins when placed in a powerful magnetic field. The underlying principle is that all the nuclei are electrically charged and many have spin. Transfer of energy is possible from base energy to high energy levels when an external magnetic field is applied. The transfer of energy occurs at a wavelength that coincides with the radio frequency. Also, energy is emitted at the same frequency when the spin comes back to its base level. Therefore, by measuring the signal which matches the transfer, the processing of the NMR spectrum for the concerned nucleus is yielded. When molecules align in the direction of magnetic field, then the spin is plus 1 by 2, while when they align oppositely, then it is minus 1 by 2. Spectrometer. Basic function of a spectrometer is to take in light, break it into spectral components, digitize the signal as a function of wavelength, and read it out and display it through a computer. In most spectrometers, the divergent light is then collimated by a concave mirror and directed onto a grating. It was invented by Robert William Bunsen in 1859. Okay, now there are the types of spectrometer. So there is mass spectrometer, NMR spectrometer, and the optical spectrometer. In this slide, the whole process of NMR spectrometer is diagrammatically explained, and this shows the working of the process. Then comes the instrumentation of NMR. There is sample holder. It is a glass tube which is 8.5 centimeter long and 0.3 centimeter in diameter. There's magnetic coils. Magnetic coil generates magnetic field whenever current flows through it. Permanent magnet. It helps in providing a homogeneous magnetic field at 60 to 100 megahertz. Then there is sweep generator that modifies the strength of the magnetic field which is already applied. Then comes radio frequency transmitter. It produces a powerful but short pulse of the radio waves. Radio frequency, it helps in detecting receiver radio frequencies. RF detector, it helps in determining unabsorbed radio frequencies. Then comes recorder. It records the NMR signals which are received by the RF detector. Then comes the readout system, a computer that records the data. Okay, so the steps of the process are that we place the sample in a magnetic field, we excite the nuclei sample into nuclear magnetic resonance with the help of radio waves to produce NMR signals. These NMR signals are then detected with sensitive radio receivers, and the resonance frequency of an atom in a molecule is changed by the intramolecular magnetic field surrounding it. This gives details of a molecule's individual functional groups and its electronic structure. Nuclear magnetic resonance spectroscopy is a conclusive method of identifying monomolecular organic compounds. This method provides details of the reaction state, structure, chemical environment, and dynamics of a molecule. This block diagram explains all the steps that I mentioned earlier, like receiving the signal from RF source, then to the transmitter, to the receiver, and then finally the signal processing. Then comes applications of NMR. NMR spectroscopy is a spectroscopy technique used by chemists and biochemists to investigate the properties of organic molecules, although it is applicable to any kind of sample that contains nuclei possessing spin. The NMR can quantitatively analyze mixtures containing known compounds. NMR can either be used to match against spectral libraries or to infer the basic structure directly for unknown compounds. Once the basic structure is known, NMR can be used to determine molecular conformation in solutions, as well as in studying physical properties at the molecular level, such as conformational exchange, phase changes, solubility, and diffusion. Nuclear magnetic resonance spectroscopy is widely used to determine the structure of organic molecules in solution and study molecular physics and crystals, as well as non-crystalline materials. NMR is also routinely used in advanced medical imaging techniques such as magnetic resonance imaging or MRI. Nuclear magnetic resonance spectroscopy is a method which can rapidly analyze mixtures at the molecular level without requiring separation or purification steps, making it ideal for applications in food science. Okay, so this is it for my presentation. Thank you.